Good day, everyone. My name is Bonaventure Lau, and I'll be talking about my final year project, which is the classification of motor imagery electroencephalogram signal using deep learning for robotic wheelchair directional control. I would like to start by pitching my idea. In this modern era of increasing population, many people suffer from amyotrophic lateral sclerosis syndrome. This neurological disease is hereditary. 5 to 10% of people who have it was caused by mutation in one of several genes. Thus, this kind of project is investigated to help people with this kind of syndrome. So the current situation, if I may use our late Stephen Hawking, he used an infrared switch mounted on his spectacles, which can be moved by twitches in his cheek. He used a motorized mobility wheelchair until the ALS took over his voluntary control of his hands. So what happens if this disease takes over all our voluntary muscle cells? The limitations of my project is that it's still in a prototype stage. So it will take some time before it is rolled to the general public. The solution for my project is that the development of EEG-based motor imagery signal classification using CNN algorithm, or which is called convolutional neural network algorithm. The deployment of the algorithm on a robotic wheelchair for directional control application. It is better because it uses an ARM microprocessor, which is cheaper and requires less power and uses less parts to assemble. Now I would like to show a demo of my project.
Good day, everyone. Today I will be showing my project demo, which is regarding the classification of motor imagery EEG signal. It's to collect live EEG signal continuously and classifying it using the model that was tested. As you can see here, a while loop was created to collect the data without setting up the board every time we need to run the program. And now we run the program. As you can see, the red light indicates that it is collecting EEG signal from the subject. Once the collection is done, it is now training using the TensorFlow. As you can see here from the terminal, a 1 is indicated at the bottom of the terminal. That means the directional control of the live EEG signal is pointing to the right. And at the bottom here, you can see press enter without any string to continue. So when I press enter, the loop will initialize again. This is the end of my project demonstration. Thank you.
So I would also like to note that the subject has no feelings of discomfort when the project was ongoing. The target segment of my project is towards handicapped people, injured soldiers, people who are suffering from paralysis, people suffering from ALS syndrome, post-rehabilitation patients, and post-epilepsy patients. The impact of my project is able to read EEG signal with ease and also a continuous prediction of live EEG signal. That is all from me. Thank you.